Okay, light has a wavelength of 356 nanometers in the glass. It passes from the glass into water with an index of refraction of 1.33. Okay, so let's draw ourselves a picture here. So here is glass, and we don't know the index of refraction, right? Okay, and here is the water. N equals 1.33, right? And then we've got this. Okay, so let's see. I feel like it's gonna go. The glass is, incident angle in the glass is 29 degrees. So remember, incident angles are measured like that. So that's 29 degrees. And then this guy is 37. So you can tell already that this is faster than this. Okay? So what's the index of refraction in the glass? I'm going to go N1 sine theta 1 equals N2 sine theta 2. So this is A. N of the glass times the sine of 29 equals 1.33 sine of 37. All right, it can be solved. N is, I'm going to go this times this divided by this. So 1.33 sine of 37 divided by sine of 29. I'm getting 1.65. And there's no units for index of refraction because it's a ratio of velocities, right? What is the wavelength of the light in the water? Ooh. Wavelength of the light in the water. Oh dear. Okay, well, let me just show you the simple way to do this is that it's going to be, in the water, it's going to be longer because it's going faster in the water, okay? So the simple way to do this is to just take the 356 and multiply by the ratio of these indices of refraction, right? So it's going to be 1.65 over 1.33. Now, the reason I'm doing this is that it's going to be a longer wavelength in the water because it's faster in the water. This is 1.65, which means it's slower here, it's faster here. So as it speeds up, it's like cars on the freeway, they get farther apart. Okay, so this is the way I would do it. So let's see, 356 times the answer I just got divided by 1.33, and I'm getting 442 nanometers. Now, if you don't believe that, the other way to do it is incredibly painful. Okay, we know that it's 356 in the glass, right? So we got to figure out its frequency, but first we have to figure out the wavelength in the glass, right? Then we have to figure out we got to figure out the velocity in the glass. Then we have to figure out the frequency. That same frequency occurs in the water. Then we have to figure out the speed in the water. And then we figure out the wavelength in the water, okay? Trust me, you will get 442 nanometers if you do that. Okay, let's see. What is the critical angle of the glass-water interface? Okay, so this is going to happen in the glass because this is the slower medium, right? Okay, so we're going to go 1.65 sine of the critical angle, okay, is equal to 1.33 sine of 90. Okay, so we make 90 degrees be in the faster medium, right, which basically the critical angle is going to be the inverse sine of 1.33 times 1, right, divided by 1.65. So let's go inverse sine of 1.33 divided by that 1.65. And I'm getting 53.666 or 53.7. All right.